In this lesson, we will delve into the assembly process of modular fixtures within the types and principles of automated fixtures discussed in Project 2. Modular fixtures, as an efficient and flexible fixture system, are widely used in modern machining. We will thoroughly explore each step from initial preparation to final inspection, mastering the key points and techniques of its assembly. This is crucial for those of you who will be engaged in machining-related work in the future. In the field of machining, modular fixtures are a very important type of automated fixture. They consist of a series of standardized components that can be flexibly combined according to different machining needs to accommodate various workpiece clamping requirements. Next, we will provide a detailed explanation of the assembly process of modular fixtures. Before assembling modular fixtures, we need to make thorough preparations. This mainly includes familiarizing ourselves with the workpiece and process requirements, selecting appropriate components, and cleaning the components. Familiarize with the workpiece and process requirements. First, it is essential to have a clear understanding of the shape, dimensions, precision requirements, and machining process of the workpiece to be processed. For example, if the workpiece is a cylindrical shaft part that requires turning, we need to design the fixture structure based on the diameter and length of the shaft, as well as the characteristics of the turning process. Additionally, it is important to consider the positioning and the clamping method of the workpiece to ensure its stability and precision during the machining process. Select appropriate components. Based on the workpiece and process requirements, choose suitable components from the modular fixture component library. The types of modular fixture components are numerous, including base components, support components, locating components, clamping components, and guiding components. When selecting components, factors such as size, precision, and strength must be considered. For example, for locating components, ensure that their positioning accuracy meets the requirements of the workpiece. For clamping components, ensure that the clamping force is sufficiently large to prevent the workpiece from shifting during the machining process. Clean the components. Clean the selected components to remove oil stains, metal shavings, and other impurities from their surfaces to ensure the fitting precision between components. You can use a cleaning agent and a brush to wash the components, then dry them with a clean cloth. Trial assembly. Trial assembly is an important step in the assembly process of modular fixtures. During the trial assembly, we preliminarily assemble the components according to the design plan to check the fitting between components and whether the overall structure of the fixture is reasonable. First, determine the reference for the fixture, which is usually the primary locating surface of the workpiece. For example, if the workpiece uses a flat surface as the primary locating surface, we can choose a flat plate as the base component of the fixture and place it on the workbench, ensuring its surface is in a horizontal position. Install the base component. Mount the base component on the workbench and perform an initial fixation. The base component is the foundation of the modular fixture, and its installation accuracy directly affects the precision of the entire fixture. When installing the base component, use tools such as a level to measure and adjust, ensuring that its levelness and perpendicularity meet the requirements. Install other components. According to the design plan, sequentially install other components such as support components, locating components, and clamping components. During the installation process, pay attention to the fitting gaps between components to ensure that they can be accurately installed in place. For example, when installing locating pins, ensure the fitting precision between the locating pin and the locating hole to avoid looseness or excessive tightness. Check and adjust. After the trial assembly is completed, conduct a comprehensive inspection and adjustment of the fixture. Check whether the connections between components are secure, whether the overall structure of the fixture is stable, and whether the positioning and the clamping of the workpiece in the fixture are accurate. If any issues are found, make timely adjustments and modifications. Connecting and securing components. Once the trial assembly is successful, the components can be formally connected and secured. There are various methods for connecting and securing components, with common ones, including bolt connections, pin connections, and key connections. Bolt connection. Bolt connection is a commonly used method that offers reliable connections and easy disassembly. When using bolt connections, select the appropriate bolt specifications based on the size of the components and the forces they will encounter, and tighten them according to the specified torque. For example, in connection areas subjected to significant tensile forces, use high-strength bolts and appropriate tightening methods to ensure the reliability of the connection. Pin connection. Pin connection is primarily used for positioning and torque transmission. When using pin connections, ensure the fitting precision between the pin and the pinhole to avoid looseness or excessive tightness. The material for pins is usually high-quality steel to ensure their strength and wear resistance. Key connection. Key connection is commonly used for transmitting torque and axial force. When using key connections, select the appropriate key type and size based on the dimensions of the shaft and hub, and ensure the fitting precision between the key and the keyway. The material for keys is generally carbon steel or alloy steel to meet the requirements for strength and wear resistance. Inspection is the final step in the assembly process of modular fixtures, and it directly relates to the quality and effectiveness of the fixture. The inspection mainly includes aspects such as dimensional accuracy, shape accuracy, positional accuracy, and the overall performance of the fixture. Dimensional accuracy inspection. Use measuring tools to measure the key dimensions of the fixture and check whether they meet the design requirements. For example, for the locating and clamping dimensions of the fixture, use calipers, micrometers, and other measuring tools for precise measurement to ensure that the errors are within the permissible range. Shape accuracy inspection. Check whether the shape of the fixture meets the design requirements, such as flatness and straightness. Tools like straightedges and dial indicators can be used for measurement and inspection. Positional accuracy inspection. Inspect the positional accuracy between various components within the fixture, such as the relative positional accuracy between locating components and clamping components. High-precision measuring equipment, like coordinate measuring machines, can be used for measurement and inspection. Overall performance inspection. Inspect the overall performance of the fixture, including aspects such as clamping force, stability, and reliability. This can be done by actually clamping a workpiece and performing simulated machining to test the fixture's overall performance. For example, after clamping the workpiece, use a dynamometer to measure the clamping force of the fixture and check whether it meets the machining requirements. During the simulated machining process, observe the stability and the machining accuracy of the workpiece to ensure that the fixture can maintain the machining quality. Through the above standardized steps, from trial assembly to inspection, we can cultivate a meticulous and methodical approach. In actual machining production, there is no room for carelessness at any stage. Only by strictly following the standardized procedures can we ensure the quality and performance of modular fixtures, thereby improving the efficiency and precision of machining. In this lesson, we focused on the assembly process of modular fixtures. Firstly, we emphasized the preparatory work before assembly, which includes familiarizing with the workpiece and process requirements. selecting appropriate components, and cleaning the components. This is the foundation for ensuring a smooth assembly process. Next, we provided a detailed explanation of the trial assembly stage. This involves determining the reference points, installing the base and other components, and conducting checks and adjustments to preliminarily verify the rationality of the fixture structure. Then, we introduced the methods for connecting and securing components, such as bolt connections, pin connections, and key connections. Finally, we discussed the inspection stage, covering the inspection of dimensional accuracy, shape accuracy, positional accuracy, and overall performance. I hope that through this lesson, everyone can master the standardized process of assembling modular fixtures, cultivate a meticulous work ethic, and lay a solid foundation for future work in the field of machining.